Okay, now in this section we'll continue with our concept on inter-VLAN routing, but this time we are not going to use a separate physical interfaces. We'll be using the second method, that is using subinterfaces. So one of the major drawback with the previous method which we discussed in our previous section or the previous video is if you have a VLAN 10 and VLAN 20, if you want to communicate with them, we need to have two separate physical interfaces because we have two VLANs. So that's something really not recommended. So what we can do is we can go with an alternate option like inter-VLAN routing using subinterfaces. Now in this scenario, what we are doing is we are going to have these two ports in the VLAN 10 and these two ports in the VLAN 20, and we are not using a separate physical interface. Instead, we are going to use one common interface which is going to connect to the router. But now the question is, one interface, how it can be a gateway for two different VLANs. So for that, what we are doing is we are going to divide this physical interface into subinterfaces logically. Inside them, we can do like f0 by 0.10, .20, .30. You can create almost a very big number of subinterfaces. So each subinterface is acting as a gateway for each VLAN, like VLAN 10, and this subinterface will be a gateway for VLAN 20. And if I have VLAN 30, I can create one more subinterface. But at the end, physically it is only one interface, but logically it is separating into three, acting as if there are three separate physical interfaces. That is something logically we are separating. That's what we are doing on the routers. Now this way it is going to minimize the number of gateways we require. We can manage multiple VLANs with a one common physical interface by using subinterfaces. And what we do on the router side is we are going to configure this link. The link connecting on this side should be configured as a trunk. And the reason is when the VLAN 10 user is sending the traffic, it goes to the gateway, that is your subinterface, and it is going to come back on the same subinterface, right? And then going to VLAN 20. So which means this link is going to carry multiple VLAN traffic, and in case of switching concept, what we have learned is the trunk link is going to carry multiple VLAN traffic. So that's something what we are going to do. So it's a complete three-step process. The first step, we are going to assign the ports 1 and 2 in the VLAN 10. So let me write down in my screen here. So what we are going to do is the first step, we are going to assign port number 1, port number 2 in the VLAN 10. So this is something I already did, and port number 3 and 4 in the VLAN 20. So these two ports are in the VLAN 10 and these two ports are in the VLAN 20. So in the second thing, we are not using a separate physical interface. We are going to configure f0 by 20 port, which is connecting to the router, will be configured as a trunk port, and that particular trunk port, so trunk port, which means this particular port will be configured as a trunk port because it is carrying multiple VLAN traffic. And on the third step, we are going to create some subinterfaces on the router. So subinterfaces on the router. So we'll see the commands one by one. We'll see. So let's start up with the switch here. On the switch, if I go and check show VLAN, if I'm going to continue from the previous lab, I have port number 1 and 2 in the VLAN 10 and port number 3 and 4 in the VLAN 20 as per the lab requirement. Anyway, 10 is not required. I'm not using 10 here. I think I removed the connection. So I'll remove the connection on the 10, and then I'm going to connect f0 by 0 is going to connect on port number 20 as per my lab requirement. Okay, so the second step, I'm going to configure port number 20, which is connecting on the router, switch port mode trunk. So once you make this particular link as a trunk port, it means that the f0 by 20 is going to carry multiple VLAN traffic. And the third step, I'm going to create subinterfaces on the router. So let me go to the command line of the router. And the first thing, already this interface is assigned with some IP addresses as per our previous lab. So I'm going to remove them. Okay. So just remove them, make them, ensure that we don't have any of the previous lab configurations which is conflicting with this lab. So I have removed all those things, and I'm going to use the interface f0 by 0, no shutdown and no IP address. So if before you create the sub interfaces, we need to ensure that our physical interface has to be in up state, and that something can be possible on with a no shutdown command. And then we need to ensure that we also remove the IP addresses if it is already present. And then to create a sub interface, just you have to give dot here and then any number. That's it. So creating the sub interface is very simple. F0 by 0 dot 10. It can be any number, but I prefer the same number. What is a VLAN number? That is something recommended. And then we need to say encapsulation dot 1 cube 10. Now what this command will do is, this command tells that this sub interface is a gateway for VLAN 10, and this number must be the exact VLAN number. That is mandatory, because when you are creating a sub interface, automatically the router will not decide it is a gateway for which VLAN. So we are saying that this is a gateway for VLAN 10, which means it is going to accept the traffic from VLAN 10, and that's what this command is going to do. And then we need to say IP address. IP address, whatever the gateway address we decided. As per my network, I'm using 192.168.1.100 is the gateway address for VLAN 10 users. Done. And then interface F0 by 0 dot 20. Now the same thing I need to do for another VLAN, encapsulation dot 1 q20, and then switch port, IP address 192.168.2.100, and then 255.255.255.0. So now if I verify show IP interface brief, now there is a default physical interface which we are not using for anything. It is just unassigned, but we are creating two separate sub interfaces on the routers for inter-LAN routing. Now the verification, we can go to any one of the PC. If you go and check the PC, which is my 1.1, I'm trying to ping to 192.168.2.1. I should get a reply. So the traffic goes to router, and the router has to forward back on the same interface in the form of a sub interface. You can see it's going, and if you try to trace it, it's going to give the same output here. So this is how we can do inter-VLAN routing by using a separate physical interface. So let me just quickly summarize what we have seen. In case of inter-VLAN routing, what we need to do is we need to ensure that these two ports are in the VLAN 10 and these two ports in the VLAN 20, and then there should be a trunk link configured, and on that particular trunk link we need to ensure that it should be configured as a trunk. And then on the router side we need to create sub interfaces, and when you're doing some troubleshooting in the sub interfaces, we need to ensure that we are giving the right VLAN number on the right sub interface. Like this should be the exact VLAN number. Now when you do this, it is going to be the gateway for VLAN 10, and this should be on the same network as the VLAN 10. The gateway also should be on the same network as the VLAN 10.